Hey, it's Chris. You got talk about controls? Have you ever reached the end of a project and heard someone say, "Why aren't the controls done yet?" That question usually gets asked at closeout, but the answer often started much earlier. It may have started with an unclear sequence, an undefined integration, a missing point map, or an assumption about who was responsible for something that never made it into the specification. So let's look at a different question. Are the controls really taking too long at the end? Or are they just revealing decisions that were never fully made at the beginning? Let's look at building automation from design through long-term operations. We'll look at how specifications influence scope, coordination, sequencing, integration, commissioning, documentation, and of course, owner turnover. The goal is not to identify problems, but to understand how better questions and clearer documents can prevent them. When building automation becomes a closeout problem, it's rarely because the problem started at closeout. BAS issues are often discovered late because the system depends on nearly every other part of the project being complete. Building automation is often blamed at the end of the project because it's one of the last systems to be fully tested. The reality is that many BAS closeout issues are a result of unclear expectations early in the project. If the specification does not clearly define the scope, responsibility, sequence, integration, and turnover, those gaps will eventually surface during closeout. A better closeout starts with better design intent and better specification language. The BAS scope changes shape as the project moves from design intent to real-world operation. We begin with design, where owner needs and system expectations should be defined. Then we move into bidding, where the specification must create a clear and comparable scope. Coordination is where the BAS begins touching other trades, systems, and owner requirements. Installation is where the drawings and specifications become physical devices, wiring, panels, sensors, and network connections. Startup is where the systems begin to communicate, but communication alone doesn't prove performance. Commissioning is where the BAS should prove that the system works according to the sequence. Closeout is where all unfinished issues, documentation, training, graphics, and acceptance criteria all come together. Operations is the real test, because the owner has to live with the system after construction is complete. Before a BAS specification can be written well, the project team needs to understand how the owner expects the building to operate. Early design should begin with owner's operational intent. The BAS should not be specified only around the equipment. It should be specified around how the building needs to perform. A school district may need simple scheduling, room-level visibility, and alarms that help small facility teams respond quickly. Where a hospital may need tighter monitoring, more redundancy, stronger alarm management, and better documentation of critical spaces. A university may need integration across multiple buildings, a central dashboard, energy reporting. Staffing matters because a BAS should match the people who will operate it. Reporting matters because many owners now need data for energy, sustainability, maintenance, and compliance. If these systems are not understood early, the specification may only describe a system that gets installed, but never truly serves the owner. BAS specification is not just a controls contractor's scope. It is the project's instruction manual for how the building should operate. The BAS specification influences far more than the control contractor's scope of work. It's not just a product description. It defines what the system is expected to do, how it connects with other systems, and how success will be verified. Scope language determines what's included and what's excluded. Coordination language determines which trades are responsible for which pieces. Sequence language determines how the building is expected to operate. Integration language determines how equipment, meters, lighting, access control, and other systems communicate. Commissioning requirements determine how the performance is tested. Documentation requirements determine what the owner receives at turnover. Training and handoff requirements determine whether the owner can actually use the system after the project is complete. When the specification is vague, these decisions get pushed into construction, where they're more expensive and more disruptive to resolve. The BAS scope should become more specific as the project moves from concept to coordinated design. Design development is where the team should define what the BAS must actually do. It's not enough to say that the project includes controls. The specification should identify which systems are controlled and which systems are only monitored. It should define which third-party systems must integrate with the BAS. It should identify which data points need to be trended and why those trends matter. It should define alarms that are meaningful to the owner, not just every possible alarm a controller can generate. It should also consider the owner's team and how they'll use the BAS on a day-to-day basis. The best BAS specification connects system functionality to real-world operation. The issue is not always where the BAS is specified. The issue is whether the responsibilities are clear enough for the project team to build from. BAS has traditionally lived in Division 23 because HVAC controls are a major part of the system. That approach can work well when the BAS scope is mostly limited to mechanical equipment. Modern automation is often broader than HVAC. BAS may include lighting controls, access controls, metering, dashboards, cybersecurity, and enterprise-level integration. When these systems are spread across Division 23, Division 26, 28, and other sections, the coordination gaps become more likely. One trade may assume another trade owns the integration. One section may require data that another section doesn't provide. Division 25 can help when project needs to unify automation strategies. The bigger point is not that every project must use Division 25. The bigger point is that the specifications must make clear responsibilities wherever the BAS scope is located. A BAS doesn't create design intent. It executes the design intent that was clearly written or tries to interpret the intent that wasn't written. Sequence of operation are the heart of a BAS specification. A point list tells the contractor what's connected. A sequence tells the contractor what the building is supposed to do. Good sequences are project-specific, not just copied from previous jobs without review. They describe how the system operates in occupied mode, unoccupied mode, warm-up, cool-down, morning start, night setback, and so forth. They explain what should happen during alarm states, safeties, overrides, and equipment failure. They're written in a way that can be tested during commissioning. If a sequence can't be tested, it's difficult to prove that it was actually delivered. Incomplete sequences force the controls contractor to interpret design intent in the field. This is one of the most common ways that design issues become a closeout issue. A clear points list is helpful, but responsibility must also be assigned for each device, connection, and data point. Points lists are important, but they don't solve every coordination problem themselves. The team also needs to know who owns each part of the work. One device can involve several parties. A sensor may be provided by the BAS contractor, installed by the mechanical contractor, and wired by an electrical contractor. A meter may be provided under electrical, integrated by controls, and used by the owner for energy reporting. Packaged rooftop equipment might come with a factory controller, but the BAS contractor is expected to integrate it. Without a responsibility matrix, each party may make different assumptions. Those assumptions often don't surface until startup or closeout. The clear matrix should define who provides, installs, powers, wires, programs, maps, trends, alarms, tests, and documents each required item. The clearer the BAS scope is during bidding, the fewer surprises the project team will face later. Bidding is where specification clarity becomes financial clarity. If the BAS specification is vague, each bidder may price different interpretations of the scope. One contractor may include integration gateways, while another excludes them. One contractor may include detailed graphics, while another includes only basic equipment screening. One contractor may include trend setup and alarm routing, while another assumes that it'll be handled by the owner. These differences may not be obvious when the bids are compared. The lowest number may simply represent the least complete interpretation. Clear BAS specifications help bidders price the same work. That reduces exclusions, RFIs, change orders, and closeout disputes. Better bidding documents lead to a better project delivery. The BAS submittal process reveals whether the specification is clear enough to become a working system. Submittals are often the first time a written BAS specification is translated into actual control system design. A good BAS submittal should show how the system will be built, connected, programmed, and operated. System architecture diagrams should show the controllers, networks, servers, and communication paths. Controller layout should show how equipment is assigned and how the capacity is planned. Wiring diagrams should clarify how the devices are connected. Points list should show what is being controlled, monitored, trended, and alarmed. Integration maps should identify third-party systems, protocol requirements, and data expectations. Graphic samples help align expectations before the owner sees the final interface. If the specification is unclear, the submittal process is usually where that confusion begins to show up. BAS coordination is difficult because the control system depends on work performed by many other trades and vendors. The BAS touches nearly every part of the building. The mechanical contractor provides the equipment that the BAS controls. The electrical contractor may provide power, starters, disconnects, and network pathways. Low voltage contractors may be involved with cabling, security systems, or access controls. TAB relies on the BAS for overrides, readings, and equipment operation. IT controls network requirements, security standards, and remote access approval. Package equipment vendors control the factory controllers, their communication cards, and their startup support. Commissioning agents rely on the BAS to verify performance, and the owner ultimately relies on BAS to operate the buildings. Because so many different parties are involved, the specification must define coordination responsibilities clearly. This is where the phrase, "it comes with controls," can become one of the most expensive assumptions in the project. Factory-mounted controllers can simplify equipment operation, but they can also create BAS scope gaps if integration is not clearly defined. Package equipment is one of the most common sources of BAS closeout issues. Many units now arrive with factory-mounted controllers. These controllers may be expected to communicate with the BAS through BACnet, Modbus, or another protocol. That project team needs to define the level of integration that is required. It's not enough to just say, connect to BAS. The specification should define required points, writable commands, alarms, schedules, set points, and trend data. It should identify who provides communication cards, gateways, licenses, and startup support. It should also identify who's responsible for troubleshooting when the communication does not work. Without that clarity, package equipment can become a late project finger-pointing exercise. Modern BAS projects require IT coordination early enough to avoid startup, access, and security delays. Building automation is now part of the building's technology environment. That means IT coordination is no longer optional. The BAS needs network drops, static IP addresses, VLAN assignments, firewall rules, DNS entries, certificates, and more. These requirements can take time to approve. If they're discovered during startup, the project may be delayed even though the controls contractor is ready to proceed. Cybersecurity expectations should also be defined in this specification. This includes password policies, account permissions, remote access rules, encryption expectations, and approved communication methods. BAS cybersecurity does not need to make the system impossible to service. It does need to be coordinated intentionally with the owner's IT. Small installation decisions can have a major impact on BAS performance, serviceability, and final acceptance. Installation details are often where unclear specifications become real field problems. Sensor location affects comfort, accuracy, and occupant satisfaction. Control wiring requirements affect labor, routing, conduit, plenum compliance, and separation from power wiring. Power requirements affect whether controllers, panels, actuators, and network devices can be installed where they're needed. Network drops affect whether the controllers can communicate. Labeling affects troubleshooting and long-term maintenance. Panel access affects the owner's ability to service the system efficiently. Device addressing affects startup, integration, and future expansion. These details may seem minor during the design, but they can become expensive to correct after the ceilings are closed and the spaces are already occupied. Online does not mean operational. Communicating does not mean commission. A BAS device can be online and still not correctly programmed, tested, trended, alarmed, or ready for the owner. Startup is an important milestone, but it shouldn't be confused with completion. When a controller or device is online, that only means that the communication has been established. The team still needs time to verify that the points are mapped correctly. Units and scaling must be checked. Inputs and outputs must be confirmed. Control logic must be reviewed against the sequence of operation. Alarms must be tested. Trends must be active. Graphics must display accurate values and provide usable data. Many closeout problems happen because online is treated as done. A better specification should define what startup includes and what must be verified before the system moves into commissioning. Test and balance depends on the BAS, so the specification should define how those activities are coordinated. The tab contractor often needs the BAS to command equipment into specific operating conditions. This may include fan speeds, damper position, valve position, heating and cooling, or VAV box airflow settings. The BAS may also provide readings to be used during balancing. If those readings are inaccurate or unavailable, tab can be delayed. VAV calibration often requires coordination between the BAS contractor and the tab contractor. Hydronic balancing may require valve control, pump operation, pressure readings, and temperature data. The specification should define expectations for the BAS during tab. It should also define what must be completed before tab begins. Poor tab coordination can become a controls closeout issue, even when the root cause is scheduler readiness. Commissioning should prove that the BAS performs according to the sequence, not just that the devices are connected. Commissioning is where the BAS performance is often proved. Point-to-point checkout confirms that inputs and outputs are connected and reading correctly. Functional performance testing confirms that the system operates according to the specified sequence. Trend reviews show how the system performs over time. Alarm testing confirms that critical conditions are detected and communicated properly. Seasonal testing may be needed for systems that can't be fully verified during the original construction season. Issue tracking is important because deficiencies need ownership, priority, and resolution dates. The specification should define what commissioning requires and what documentation proves completion. Without clear acceptance criteria, commissioning can become subjective. Clear commissioning requirements help the project team agree when the BAS is actually complete. This is where everything we have talked about comes together. Because closeout doesn't create the issues, it collects them. At closeout, every unresolved BAS expectation becomes visible to the owner. BAS often becomes the last visible problem because it depends on so many other things to be complete. Equipment must be installed and powered, networks must be available, packaged equipment must be started, tab must be completed, sequences must be programmed and verified, graphics, alarms, and trends must be built and reviewed. The documentation must reflect the installed system. Training must prepare the owner for actual operation. If any of these expectations were unclear, they often surface at closeout. The BAS becomes the place where all unresolved coordination issues are finally exposed. This is why better specification is so important. BAS closeout documentation should help the owner operate, maintain, troubleshoot, and modify the system after construction. Closeout documentation should be more than just a binder or a file transfer. It should give the owner the information they need to operate and maintain their BAS. Final drawings should show what was actually installed. Program backup should be provided in a usable format. Network architecture should document how the BAS communicates. Device lists should include controllers, sensors, meters, gateways, servers, and any major integration. Alarm setup should identify alarm priorities, routing, notification, and expectations. Alarm setup should identify alarm priorities, how they're routed, and the notification expectations. Trend setup should document what is being trended and why. Warranty information should be clear. Training records should show who was trained and what was covered. Good documentation supports long-term serviceability. Poor documentation turns every future issue into a detective project. The BAS handoff is only successful if the owner's team can confidently use the system after the project team leaves. Owner training should be designed around the people who will actually use the system. Training shouldn't happen simply because the specification requires it. It should prepare the owner's team for daily operation. The training should cover system navigation, schedules, set points, override, alarms, trends, graphics, and basic troubleshooting. It should also explain what users should not change without support. Many owners need training after they've occupied the building and used the system for a short period of time. Follow-up training can be more valuable than a single session at substantial completion. A good handoff reduces frustration and builds trust in the BAS. A poor handoff can make a good technical installation feel like a bad system. The project team leaves at closeout. The owner lives with the BAS every day after that. The real measure of a BAS's success is whether the owner can use it to operate the building efficiently over time. The project may be over, but the BAS is critical to the building's operation and management. A successful BAS is understandable to the owner's team. It's serviceable by qualified personnel. It's secure enough to protect the owner without preventing practical support. It's usable for daily operations. It's adjustable as the building changes. It's trusted because the data, alarms, graphics, and sequences make sense. This is where specification quality has a long-term impact. Good specifications do not just help in construction. They help the building remain operational, maintainable, and usable over its life cycle. Most recurring BAS closeout problems can be reduced by clearer specification language and early coordination. If the scope is vague, the specification should define responsibility more clearly. If the sequences are incomplete, they should be written so that they're project-specific and testable. If integration gaps are common, the specification should assign ownership for gateways, devices, point mapping, and verification. If trends are missing, the specification should identify required trends, what their intervals are, how long they should be retained, and what their purpose is. If IT delays are common, IT coordination should begin during the design instead of startup. If acceptance criteria is weak, the specification should define what complete means. These fixes don't eliminate every construction challenge, but they do reduce ambiguity. Reducing ambiguity is one of the most valuable things a good specification can do. Better BAS specifications begin with better questions before the first section is written. Designers should ask these questions before writing the BAS specification. What does the owner actually need to operate on a daily basis? Who will use the BAS, and what will their level of technical experience be? What systems must integrate, and what level of integration is expected? What data must be trended for troubleshooting, commissioning, energy management, reporting, and compliance? What does IT require for network access, cybersecurity, remote support, and user management? How will performance be verified during startup and commissioning? What documentation does the owner need to maintain the system after turnover? What does successful handoff look like from the owner's perspective? These questions help clarify scope, responsibility, performance expectations, and turnover requirements. Better questions lead to better specifications. Better specifications reduce late project disputes. Most importantly, better specifications can help the owner receive systems that they can actually operate. The goal isn't just to close out the project. The goal is to deliver a building that works better after everyone leaves. That's it for today. Thanks for spending some time with me. If this topic connects with what you're seeing on your own projects, reach out. We can talk through ways to reduce BAS closeout delays, how to clarify expectations early, and how to help make sure that the owner gets the building that they can actually operate. I may not have every answer, but I do know this. Better questions lead to better specification. Better specifications lead to a better coordination, and better coordination leads to better closeout. Remember, a BAS closeout doesn't start with a better punch list. It starts with better questions from the very beginning. See you next time.